Okay, in this video we'll explore using the graphing calculator to do a normal probability problem. In this example, the amount of time a bank teller spends with each customer is normally distributed with a population mean of 3.10 minutes and a standard deviation of 0.40 minutes. The first question, what is the probability that a bank teller spends at least 3.5 minutes with a randomly selected customer? So the first thing I want us to do is draw a picture of this distribution. Normally normally distributed means a bell-shaped curve. The mean is 3.10, so I'll come right down where the middle is and label 3.10. The question asks, what is the probability the bank teller spends at least 3.5 minutes with a randomly selected customer? Well, one standard deviation is 0.40 minutes. So from the mean of 3.10, if I count up 0.4, I'll be at 3.5 minutes. So the question is asking about the probability a bank teller spends at least 3.5 minutes. At least 3.5 minutes means greater than or equal to 3.5. So the area under the curve to the right of 3.5 will represent this probability. In terms of a probability statement, in terms of the random variable x, we're looking for the probability that x, the time spent with a customer, is at least or greater than or equal to 3.5. Recalling from an earlier lesson that z-scores represent the number of standard deviations away from the mean for a data value, we're looking for the probability that z is greater than or equal to 1, because you noticed we counted from the mean up one standard deviation, 0.4 minutes. Now we're going to move to the calculator and look at using the normal CDF function to find the area under the curve to the right of 3.5, which represents the probability that the time spent with a customer is at least 3.5 minutes. So over to the calculator we go. Above the VARS key where distributions are, second, distributions. Using the down arrow, go to number 2, normal CDF. Come down to enter, and the calculator needs to know some information. The calculator needs 4 entries here. It needs to know, looking back at our picture, from left to right, what is the region or the interval of interest? The leftmost point of interest is 3.5. So we're going to go from 3.5 to positive infinity. Okay? Leftmost point of interest, 3.5, all the way up to positive infinity. So from left to right, the interval of interest. Then the third piece of information the calculator needs is our mean, which is 3.10. And the last piece of information the calculator needs is our standard deviation. So always those 4 pieces of information in that order, from leftmost to rightmost points of interest, mean and standard deviation. So back to the calculator to enter these. 3.5, separating with commas each entry. The comma is above the number 7. Here it is. We don't have a number for infinity. That's the idea of infinity. We don't have a button for it, therefore. So you can either enter a very large number, or I prefer using second E99. Second E99 represents 1 times 10 to the 99th power. Very large number. I'll make a note of it over here. So we're using second E99. And then a comma, back to our calculator, a comma for 3.10, our mean, comma, and finally our standard deviation, 0.4. Then I'll close the parentheses, ending the entries that the normal CDF needs. Come to enter, hit enter, and there is our answer. So back to our notes. We come up with 0.1587. I also like to label this on our picture 0.1587 so that I can see that area listed. So it turns out that there's a roughly 16% probability that a bank teller spends at least 3.5 minutes with a randomly selected customer.